Really happy to be sitting here with Nick from LabDAO. LabDAO is a spin-off out of Molecule, as far as I understand.
Yeah.
So Molecule spun out VitaDAO, and then VitaDAO spun out
but
LabDAO.
we work very closely with Molecule. Yeah.
Okay. And you guys are building a decentralized network of laboratory facilities, equipment, that kind of thing?
Right. So at LabDAO, we believe that open tools accelerate progress, and what scientists need, decentralized scientists need, is they need actually access to laboratories beyond just being able to think through the funding and think through the scientific experiment they want to do and raise the funding online, which is something they can do already within organizations like VitaDAO. They also need to be able to actually execute the experiment that they're planning. And for that, we basically need to abstract physical laboratories in a way in which they're accessible online. And we cannot actually build the lab right away, and maybe we don't even have to. We can just use the labs that are already out there, and we develop open source software called Lab Exchange. It's a peer-to-peer exchange protocol, in which every scientific institution, but also CRO, core facility can participate in and can offer laboratory services. And the whole philosophy is that there are more and more laboratory services in biotechnology that can be simplified to the point that they feel like an API. Mm-hmm. For example, I give you an amino acid sequence for a protein. It's like a building block of our body, and it's at the core of a lot of medicines. I can actually, as an input, I can just give you that sequence, and then if you manufacture proteins, you can return the protein back, and you give me a couple parameters around how that look like. But it's becoming increasingly routine that I think we're at a point in sort of the industry that asking someone to synthesize a protein should be something that feels a bit more like an API call than like 12 Zoom calls and like legal documents that have to be sent and signed.
Yeah. So are the lab facilities around the world at the moment, are they underutilized in the sense that they're not being booked out?
Yeah, there's a lot of lab space that is not effectively used. And at the same time, if you're watching this in places like Boston, San Francisco, and also like Central Europe, then you will have to chuckle, because actually in those cities all the lab space is packed. You cannot rent lab space.
Right.
So there's this huge asymmetry, this inefficiency in this sort of market where in these like big biotech clusters, all the lab space is sort of booked out. But then actually once you in other regions, and especially also when you have a company and you have a lot of lab space that you purchase, then actually the machines are not working every day.
Right.
So why are the machines not working every day? Why are, for example, robots standing still? And I think that's just a huge inefficiency in the market. And if we can build a protocol in which services can be abstracted to the point that you can just ping an API and then a robot or like a laboratory could just be used as much as possible, then I think we can just increase the whole productivity in the biotech industry.
Okay. So going back to what you were saying earlier, you can send a message to a robot somewhere, and that will synthesize a protein or synthesize amino acids together.
Yeah, this is just an example, really, and on a high level, we're not yet at a point where we can directly instruct robots. It's more like I'm sending you an email to like a real person, but it's extremely standardized, so you know exactly what to do, and you don't need to get on the phone with me.
Yeah.
You literally have, this is the instruction, you have all the details you need, the money, the tokens are in the escrow. You have all you need to get to work, and then hopefully just sort of lower the transaction cost that is associated with getting these biotech services done.
Yeah. So why, once you've synthesized a protein, why does it need to be done again, like for each individual experiment?
Oh, I mean, this is just an example, but when you are in the business of, for example, producing proteins that have particular functions, you usually don't know whether the proteins that you synthesize, whether the protein that you're generating is actually working. So you have, for example, a protein that is supposed to bind to a particular drug target, a gene that is associated with a disease. Now you don't know whether the sequence that you just submitted, whether that protein is actually going to bind to that target very tightly.
Okay.
So it often takes a couple rounds of testing, and the same goes for enzyme manufacturing, which is another class of proteins. There's just a lot of transaction volume that I think is currently happening in very inefficient ways, where you have to have multiple. It's really multiple Zoom calls. You have to find these CROs like through friends that are with you in the biotech industry, and then you sign legal documents, you sign NDAs, and you exchange the currency using fiat. And I think it just could be so much more efficient and basically create a global market for these services if we just use smart contracts instead of real contracts, and instead of having these contract research organizations, we have smart contract research organizations.
Okay. So I think something I'm still missing is, so going back to this protein, is there a chance that somebody else in the world has already done that experiment?
Yes. So actually, there is the chance, and the whole idea is with the lab exchange that every transaction leaves a trace. Every transaction mints an NFT.
Right.
Basically, the exchange is a collaborative NFT minting game. So I give you, as an NFT, you always have data assets that are exposed to IPFS, and they're referenced in a JSON file that adheres to, for example, ERC 721 standard. And usually when you purchase an NFT at OpenSea, you have some attributes to your Pudgy penguin, and then you have the picture of the penguin itself being referenced in the JSON, right? Yeah. So the way that we think about it is, well, when I request a protein to be synthesized from you, I start writing JSON. I start saying, this is a protein, this is the amino acid sequence, but I don't know how it looks like and whether it binds. I just leave those fields empty, and then I pin that to IPFS, and I say, here are 30 tokens. Can you complete the NFT and send me the NFT back that is complete? Okay. So every transaction is a token.
And it's kind of what's the word? So it's hashable in the sense that if you have the same inputs, you get the same output.
Well, biology unfortunately doesn't really work that way.
Okay.
But so there is always stochasticity. Okay. So we need to accept that the output, if you hash it, will never be exactly the same. Right. However, you can at least look whether someone has already submitted the same input. And then you can say, oh, this transaction has already been done. Oh, this was the result. Do I want to resubmit it anyway because I want to get a better understanding of the stability of the result? Or am I at the point where I say, oh, this is good enough. I'm just going to use the result that someone else already did. Yeah. Now, the next question is, this makes a lot of sense for like open source biology, basically academic research. But you also want to enable biotechnologists that they have valuable intellectual property to protect their asset. So these NFTs, the way that we're currently developed them, and again, sort of what I'm describing, this is something that's literally built as we speak. So we're early. We're early. We're still pre-launch with LabDAO. But what we're implementing relatively soon is that this NFT and the data assets themselves, they're threshold encrypted using something like LIT protocol. So only the owner of the NFT can actually access the data. Yeah. So I initiate the transaction. So I basically send you this half-baked NFT template. Mm-hmm. You fill it out. You symmetrically encrypt the data assets, and then use something like LIT protocol or other services, and you send me the token back. And then the whole network knows Niklas owns the NFT, so only Niklas is able to get the key that's required to decrypt that file that is pinned to IPFS. Okay. So how is that searchable for other researchers who want to make sure they're not duplicating work? Yeah, so you can, in principle, search all of the NFT metadata already through a subgraph that we put on the graph protocol. Okay. But we're also actively developing open source tooling to make it even more accessible. Mm. And what's really exciting is that I think of DAOs really as they're sort of associations of both individual people but also entities. So you can have a company be part of a DAO in my logic. And so we're really excited and fortunate to be working with some startups that are focused, for example, on mining biomedical knowledge graphs and presenting them in a good way. So we can actually have them as DAO contributors, and they earn like their governance tokens hopefully in the future by basically contributing to the open source community and then helping us maintain this common good.
Okay, so we'll come to the Web3 aspects in a bit. But, you mentioned reproducibility.
Yes.
This is a key principle in science, right? That if somebody asserts that some molecule or whatever will work on a certain disease,
Right.
then there's a burden of proof on them or on somebody else to reproduce it and to make sure that research is valid, right?
Well, it should be that way. And there's the saying that one should rather build houses of bricks than mansions of straw. Right? You rather if you make a scientific claim, you rather be really sure that the claim is accurate, and because that is then a good stepping stone for the next scientist to build upon.
Yeah.
Now, my hope with this NFT-based knowledge graph is that scientists can track what experiments have already been done before, and then also how many times have they been done, and what is sort of the aggregate across different iterations, across different replicates of the experiment.
Yeah.
And it's very traceable for everyone to see.
Okay, amazing. Okay, so let's talk about Web3.
Yes.
Is the WEN token?
So we are literally building a research institute online. And when you think about research institutes, you want, research institutes today are really, I think, the pillars of our society, right? Everybody goes through a research institute, like a research university.
So usually government funded.
Usually government funded. Why government funded? Because they're maintaining a public good, right? They're locations where talented young people come together. They get in contact with very talented scientists. They learn something about how the world works, what are the current questions, what are the current problems, and then they do interesting research. And once in a while, that interesting research leads to something that is commercializable, and then that can be further developed and spun out. And something that I have observed, and others have too, is that over the last couple of years, I think there are basically two things. If you're not fortunate enough to be born in the United States, being an inventor is just really hard.
Yeah.
Getting the funding you need, finding the team of talented other scientists that want to do science with you, or other talented students for that matter that want to do science with you, and then getting some initial funding to light the spark is really hard. And if you're not sort of fortunate enough to be born in the right place, and that's something I completely want to change with LabDAO. It's no matter where you are, you can go in this Discord, you can ask interesting questions, find your team, build your hypotheses, design the experiment, raise funding into the experiment, and you can do science. Now that itself is a public good. So that's just sort of one part of it. But then I think something else that has a bit gone missing is that we with the traditional funding sources, we have really optimized for academic science for the sake of publications first, and not necessarily for inventions. Yeah. So when I think about technological progress, I think about scientists engaging in basic science, and then there are some scientists that they have a bit more of a chip on their shoulder, and they're a bit more impatient. We would call them inventor if they were to live in the era of Edison and Tesla. Yeah. But we don't say that anymore, right? We don't say, oh, he's not. That person,
the maverick.
Yeah, she is not a scientist. She is an inventor. We don't tend to say that much, which I think is I don't understand why we stopped saying that.
I'd love to put inventor on my LinkedIn
exactly.
profile.
Well, yeah, or actually, you would just like to show the world that you have been inventing a lot of stuff. Yeah, and so we need to sort of give more opportunity to scientists that are a bit more impatient with the status quo. They actually, yes, they use scientific principles to develop a new technology, but they want to see that technology actually impact the real world. Where if I finish this continuum, you have scientists, inventors, and then you have entrepreneurs. And we've gotten really good at funding scientists using these large government funding agencies, and we are pretty good at funding entrepreneurs that have a idea where the technological risk is relatively low, and then they go through these accelerators, and it's very clear the capital that goes into them can be a bit less patient, right? Because there's at least not a lot of technical risk.
Yeah.
Now, I hope that with LabDAO we can sort of rebundle the research university and sort of the startup initial accelerator into one thing, where we say, you come for the science, you come for maybe eventually even the education into LabDAO, and you learn something about biochemistry and the biotechnology industry. And we're just getting started there, because that's sort of the circle of competence that we have currently within the team. But then if you come together and you do interesting stuff, and you do get a bit of funding, and it develops into something more, we actually want to be encouraging the invention, and we want to encourage that to turn into a new technology, and we want to be the first to be able to support that turning into like its own project. And then that could be like basically a biotech startup that develops out of that internet community.
Okay, so with a view to commercializing it as well.
So it's trying to square something trying to bring together something that has been very separated, where you had government funding that was for nonprofits, dedicated to nonprofit science, and then you had entrepreneurial funding that was coming through venture sources. And I think if we try to rebundle this into a public good, where we say, an online DAO can get support from other online communities, or from other players in the ecosystem, to basically enable scientists to do science, but then also be the first to fund them as they spin out whatever entity they might come up with. And the odds for that are like maybe 1 in 100. But you want to still do that, right? You want to give an incentive for inventors to actually build their inventions. Then I think that can be a net good for the world, and it can also have potentially sort of a vector of financial sustainability, if not even growth.
Do you think this model can outcompete the universities in the sense that you can generate an endowment fund eventually through all of these collaborators that can compete with the Harvards and the Oxfords?
I think that we can definitely be a complementary institution to these existing institutions, because not everybody can go to these places. I personally have spent time in Boston, and then I had to leave, and then I came back. And if you're not born in the United States, getting a visa is extremely challenging. Why is it so hard? I have all these ideas, irrespective of whether I'm in Germany or I'm in the United States, and it's extremely frustrating to have to explain to people at the border why I want to do science here and not there. And I think it's having an online community where everybody, no matter where they are, can come together and raise funding for science. It's going to be, I think, a really new approach to bring scientists together, and I think it will coexist with the existing institution, and hopefully we'll be able to build an endowment that is sort of in the same ballpark.
Yeah, I think you've been quite modest, because from what I'm seeing, all of the elements of a university are being reproduced. So you've got the community. Well, firstly you've got the education, then you've got the community, you've got the funding, and you've got the publishing. So
we leave the publishing to other specialized DeSci projects, but yes, we care about that too.
Yeah. So the DeSci industry is kind of dominating the whole stack, or that seems to be the ambition.
Yeah, so when I think about the scientific stack, you brought up this idea, I think about 3 layers. There's the funding layer, then there's the execution layer, and then there's the distribution layer. So when in the funding layer, you have different science funding agencies. They don't actually do the science, they fund scientists. So I'm a core member at VitaDAO, and out of VitaDAO, which spun out LabDAO. And VitaDAO is a dedicated funding DAO for scientists that are engaging with aging research that has some kind of translational potential. And then you have on the sort of publishing, on the sort of 3rd layer of the stack, you have a lot of other decentralized science projects. Just naming a few: Adams, Research Hub, where Brian Armstrong's heavily involved, but also on the IP side, Molecule, for example, where you say, well, whatever intellectual property I generated, I can turn that into an NFT, I can abstract it into an NFT, and then it becomes a tradable asset, which is really interesting, I think, when you think that more sort of inventor or translational research. And now, I think what's currently like a gaping hole in the stack is actually bringing scientists together to do the science online, and that's where I see LabDAO.
So bringing them together online, not necessarily physically.
Exactly, bringing them together online, and then giving them the tools to the lab exchange, to this open source tool to actually book the laboratory services, and then raise the funding to book them.
Yeah.
And it all happens in an abstracted way. But then also, I think sooner than we might believe, we'll get to a point where you have a team and they all happen to be in Germany, let's say, and they say, yes, we can book all these CRO services, but we actually need to actually have a lab. And then I would like the organization to be capitalized enough such that the organization could say, well, just create a proposal, and then we vote whether we're going to put 6 figures into building you a container lab in Berlin. And
wow,
I think that would be really, really awesome if we have basically this global network of labs that are owned by an online community where scientists right now, they have a hard time inventing in a lab because whenever they make an interesting invention, they know the technology transfer office of that university, which is very much geared for nonprofit science, is going to make their life extremely hard because there's basically, you can think of it as almost like a 20% equity fee on whatever company you want to spin out of the university right now. It's extremely unfriendly. And I think there should be a world in which, as an inventor, at a university, if you make a discovery, the university should give you money to make this thing even bigger. They should be like, hey, this is extremely awesome. Can we inject capital into what you're doing so this becomes even bigger? But instead, we're living in this sort of unbundling of academic research centers, where it's the research center and then there's the VC that's managing the endowment.
Right.
So you have the research center that's trying to keep all the scientists in there, and then has a 20% equity tax on you spinning out the company. And then there's the VC fund that's literally managing the endowment of the research university, and then that injects capital into it. It doesn't compute for me, and I think we need to take that away. We need to give lab space to the inventors, permissionless, and then we just need to be smart as a DAO and identify the inventors that do really interesting stuff, and then say, hey, we have this lab fund, which is one of the 3 products. There's the lab exchange, lab fund, and lab teams that enables teams to come together very quickly. We have this lab fund that we funded through different DAOs and other donors. And can we give you some money? Can we be the first ones to fund you? And that's what we want to do. That's what I care about.
There's something that's not talked about very often, that when you sign up for a university, not only by publishing papers are you bolstering the university's reputation, but you're also agreeing that the university will own 20% of any IP that you produce.
Yeah, I mean, this 20% number is just an average I'm sort of just putting into this interview, but there's a lot of fine print around how the tech transfer offices handle it, and there's some universities that are really anti-innovation almost, where they take 40% equity claims on the company that you generate, which is like a non-starter if you're in venture. Who would ever invest in a company where 40% of the equity is owned by an institution that does not know anything about the biotech industry, where the talent is completely drained into venture capital as a business. And then there are other institutions that are a bit more progressive that take less ownership. So it is sort of a range, but all in all, I think double-digit percentages is nothing that's extremely uncommon.
Yeah.
And I think that needs to be lower, and we need to bring the ability to allocate capital efficiently back into the research organizations themselves. That sort of got unbundled over time. There was a specialized capital allocation industry that's venture, and then there's a specialized nonprofit research sort of part of the ecosystem. And I think that the two need to be brought back together. And I think DAOs are great for that, because you can have people in venture, maybe dabble in this in their free time, and you can have people that know how to run academic institutions also spend some time in the community. It's an interesting mix.
Yeah, no, it's a natural partnership, really, isn't it? So how can so there's no age restriction, right, on
Not at all.
applying for funding? You don't need to wait until you're at university. You can be Sheldon Cooper at
you can have an ANON account.
7th grade or whatever.
Yeah, if you have a good idea, you should be able to get funded.
Okay. So how can a young researcher go from 0 to 1? So say they're blowing shit up in their basement, and they get this great idea. How can they progress?
Yeah. So right now, I cannot offer them the toolbox that I would like to offer them, just given the maturity of the project. We would love to have the funding at this stage to like go and like build the labs. We need more labs, but at this stage of the project, what I can offer them is if they're into computational biology, if they're into like using machine learning to hold proteins or to generate small molecules, then I can offer them teams. We call them labs. Labs within LabDAO that are specialized in that bring people that work in major open source projects, that work in biotech companies, that are in academia. We bring them all together in a lab, and there's a small molecule engineering lab and a protein engineering lab where we bring those talented folks together, and they sort of jam together on like their scientific
So it's
interests.
a Discord channel or something?
Yeah, it's a Discord channel, literally, and we're starting to roll out NFT gating for them. So you basically get a badge that you now joined the small molecule engineering lab, and then you're part of that lab. And then we actually we have something like guilds. We call them departments, where we say, okay, there's like a whole group of labs that are interested in machine learning. So let's create a department for machine learning, or a department for graphs, where it's like knowledge graphs, but also the graph protocol. And we bring them all together. Everybody is interested in this stuff, and I think a lot of young people learn a lot by surrounding themselves with people that are interested on a scientific level in a particular topic, and then eventually we hope that there's just fruitful interaction and people come up with new ideas, and it's already been super interesting. We had people re-implement published algorithms. We had people tinker with natural language processing tools to like analyze introduction channel messages. It just really creative stuff that's already happening, and we're just a couple of weeks in. So I just want to see that grow and flourish, and then be able within the community to give them what they need in terms of funding to make it more awesome.
Amazing. So, and can the researchers also start sending requests to sequencing machines and things like that?
So we're literally building out the protocol, the lab exchange for that right now, and then it's one core activity that we'll probably use service providers for is to like actually go out and try to pull these different companies into the ecosystem.
Yeah.
As you can probably imagine, a lot of companies, especially in biotech, which is a relatively risk-averse ecosystem, they're not very into taking tokens from like an online community to do work. So we will probably have to stand up real-world entities that basically take on that risk of and making sure that KYC requirements are there when they're needed to basically offboard the transaction that are coming through the exchange, and then relaying it into the CROs until I think the technological adoption that we see of just Web3 overall in the world is sort of sufficient enough that a lot of the CROs also come around, and we can probably just go direct and open the client on our own like laptops.
Yeah.
But for the meantime, we'll probably have to relay a lot of stuff.
Okay. And so the incentive structure will be based around the lab token.
Yes. So the lab token, and this is not financial advice, and the tokenomics are not fully worked out yet. But the way that the lab token is conceptualized is that it's a governance token first, but so it allows you to make decisions, for example, around grant funding in the community. Should we buy a physical lab, for example, in a particular geography, or should we fund a particular project? Should we change the standards of physical laboratory process? It's extremely important that there are these sort of also quality assurance decisions that are made, just the way that, for example, there are international consortia that define standards for just general manufacturing. There should be basically DAOs, this international consortia that define standards for like the new type of industry we're entering, which is really biotech. So that aside, that's the governance token side. That aside, there's also a utility element to it where the token itself is used for staking and basically collateralizing the transactions that you're receiving at least as a provider. So let's go back to our protein synthesis example. I tell you an amino acid sequence for a protein I want you to synthesize. So I'm sending you this amino acid, and I'm depositing tokens, and these are all stable tokens. Lab token is not a currency.
Okay.
I'm staking an ERC20 stable token into a contract, and I'm saying, right, can you synthesize this protein? And if you're done, you send me whatever data you get from that synthesis report plus basically the NFT also representing a license for me to tell you where to ship this sample that you synthesized. Can you send that back to me? And then I see it, and let's say you were a bad actor, then you could have just sent me some completely false data, or you could just send me some fake information, but you actually never synthesized the protein. How would I know, right? Well, I would only find out maybe after the fact, after I already paid you. So to create some discipline for you and to solve this, it's called the nothing at stake problem, and make you have something at stake. So if the transaction is valued at, let's say, $1,000 or $10,000, then I make you stake at least that amount in worth of lab tokens, such that you have something to lose in this. Basically, you're putting your reputation, your membership in the club on the line. Like, you want to be part of LabDAO? You need lab tokens. You want to do big ticket transaction? Yes, please. But if you offer transactions that are extremely expensive, you also need to put your membership really at risk, such that the quality of the transactions that you're engaging with is maintained.
I think we have some kind of dispute resolution going on there.
Yeah, I think so too. Which is actually one of the mechanisms that we have too. So when you deposit the money in the escrow, this staking is just one of 3 mechanisms to try to maintain equality. The second mechanism is that if you get the NFT back and you instantly see if something is off, then you can work with an arbitration service, a mediator. That's an independent project that has sort of root access to the contract that's holding the funds, and you can try to mediate the conflict in a good way. And we're building sort of that infrastructure element out as well, and it's a lot to build. And then the third element is basically not everybody can participate in the market right away. So if you're just entering the DAO, you need to go through a process of onboarding if you want to provide protein synthesis services. So there might be a working group that's specialized in protein synthesis, and then they have a call with you. Maybe they, in the future, will even visit your lab and make sure that you actually can offer what you're claiming you can offer. And then there's a DAO vote to basically update the state of the contract to basically add you to the curated registry of validated providers. So you can only claim transactions on the exchange as a provider if you have been sort of allowed by the lab to do that. It's a bit of like there needs to be there needs to be some community gating to make sure that we maintain quality and also biosecurity. Really, I mean, I'm committed to human progress, and I want to see more inventors be able to do their work, but we also need to just be realistic about if we build an exchange that's allowing anybody in the world to synthesize molecules, that might be risky. So we need to, as a DAO, be responsible and sort of take some level of ownership in making sure that we can limit risks. And I think that's part of it.
Okay. Can you just talk a little bit about the VitaDAO approvals process? Because there's sort of a 4-tier system, right?
It's a 3-tier system. And it's very much, we tend to speak about this quite a bit, but I think in practice it's actually a bit less dramatic as it sounds. So we find an interesting project, or there's an application coming through from a scientist, and actually a lot of times we tend to source projects. And then there's a conversation in the Discord. It's literally just a thread with people that have sort of been responsive.
Like a soft proposal.
Yeah, it's we just converse around the proposal, see whether it makes scientific sense, whether there's an opportunity, at least a remote opportunity to capture some value back from having IP ownership stakes in the outcome of the experiment. And then in the second stage, it goes into a forum vote. So it's just like a discourse forum where the proposal is formalized, and then people can give feedback on it, and then it escalates into a snapshot vote on chain. It's not on chain, but you get the idea. Token based.
Although Snapshot are promising that it will be on chain soon.
Okay, I don't know that.
Hopefully. Okay, cool. And going back to something that you kind of touched upon earlier, setting standards within science. Do you think there's a chance that if LabDAO, if the ecosystem, the decentralized science ecosystem, can aggregate enough data and enough authority on how to conduct experiments and, especially longevity research. Do you think there's a chance that DAOs could actually start to begin to set, professional standards within the industry?
I'm convinced. It's actually one of my strongest convictions in all of this is that if you create a peer-to-peer exchange for laboratory services, I need to be able to communicate extremely efficiently with you because I don't even know who you are. I'm literally posting a request into the ether. I'm saying, someone please synthesize this protein. So I need to be extremely specific in what I expect you to do. And you need to have very good understanding of what I want you to do. So we basically create this, for the sake of velocity in the marketplace, we create an information pinhole. We force compression of information. Like, instead of having 2 Zoom calls where I explain to you what I want to do, there's only so many text that you could fill out into that box when you post the file to IPFS. So I force you to be concise. Now, that information bottleneck that the exchange basically presents is then very quickly, because the cost of arbitrating conflicts is so high, it's very directly pushing the community to say, okay, this is LabDAO improvement proposal 339, how we synthesize proteins in E. coli.
Right.
Right? Because otherwise chaos is going to. So if I had to think through what is the outside positive externality of such a DAO, I think creating standards for the bio industry is one of the bigger ones.
That's interesting, and that helps reproducibility, and it helps to make the whole process more efficient.
And don't get me wrong. I think whenever you do science, whenever you do research at the cutting edge, it is always chaos. It has to be chaos. And that's why we need to have scientists have access to labs where you can have these custom protocols and you tinker around. But then there's increasingly just a number of methods in biotechnology that should not be so complicated to express. That could be expressed in just a couple lines of code. And going through the challenge with a global online community of defining some of these standards, I think is exciting.
That's amazing. So how many countries are you operating in at the moment?
We have a bit more than 1,000 people on the Discord right now, so it's still a very young project, but it's been growing rapidly over the last couple of months. In terms of the global community, I think we're very much biased towards Western Europe and the United States, Canada. We want to have more people involved. I think it's also a bit of the core contributors are spread across the 2 continents, and then that sets sort of the calendar events and when the community. So it's sort of in that way. It's not extremely inclusive to an Asian community. I think we need to do a bit more work there to get everybody involved. But I would love to see that.
Okay, amazing. Well, it's been fascinating chatting to you. Is there anything else you want to add? I mean, how can people interact with LabDAO at the moment?
So you can find us on Twitter, Twitter/lab_DAO. We have a Discord that's very active. Currently, it's very much pre-launch, so the things that I told you, very much. The exchange is still in testnet. The clients are still being developed. We're just starting to onboard the first physical laboratories. So this is really just what we want to build, and we're getting there. We've made that progress, and I'm really proud of the core team that's been working on this over the last months. But if you're a Web3 developer, you can add a ton of value. If you are a computational biologist, this is your time to start building these applications. And just generally, if you really like community building and organization building, we'd love to have you. And just pop into our Discord, say hi, and figure out a way.
We're really getting drowned out now.
Yeah, we are.
Cool. Well, thanks, man. Thanks very much for your time. Blah, 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 blah. What does he want us to say? That was amazing. Thanks so much. I hope the microphones lasted.
Oh, yeah.